Hello, my name is Jawanza Joseph, and I'm talking today about Flink stateful functions and Pulsar functions and providing a comparison between the two. These are projects that I've really come to use and love and cherish, and I'm excited to talk about them and how they're different, and then also how they can be used in tandem with one another. So before I get started, I wanted to talk a little bit about the title of this talk. So it is called Paper Moon. And in the top corner of this slide, you can see this album cover by Dave Brubeck called Paper Moon. And it's highly inspired by this album. And so after this conference, feel free to give this a listen and let me know what you think and how it compares to this talk. So let me go through the agenda for this talk. To start, I'm going to do an introduction to both Pulsar functions and Flink stateful functions, just a kind of a brief idea of the philosophies between the two, how they really compare and what to look for and why you would use one versus the other. Then I want to talk about kind of the runtime characteristics, like what it takes to run these, and what is kind of the bare minimum requirements to do that. Next, I'm going to talk about the orchestration, so how these functions are orchestrated and how you deploy them, for example. Then I want to talk about the scaling, how you scale these up and down, and like what are the scaling factors for these systems. After that, I want to talk about state management, how you manage state in these two systems, and why you would need state for them. After that, I would like to talk about the ecosystems. So what makes these ecosystems unique? What types of things can you do with stateful functions or with Pulsar functions? Then I'll talk through some of the key differences between the two systems. And then throughout the talk, I'll actually provide examples, just not at the end, of like what it looks like to write a stateful function or what it looks like to write a Pulsar function. And then I'll end with some conclusions about what the differences are, what the future for these projects are, and how might they actually be more philosophically aligned than being kind of competitors with each other. So what are Flink stateful functions? So Flink stateful functions are a extension of the Flink, that's an open source Flink project, excuse me. And they are not necessarily another way to write things for the table API or write data streams. They're really a unique approach to doing microservices and doing kind of a complex stateful microservices in particular. So let's take a look at how the maintainers of stateful functions have defined their project and kind of unpack that a little bit. So they define it as stateful functions is an API that simplifies building distributed stateful applications. It's based on functions with persistent state that can interact dynamically with strong consistency guarantees. So a few things stick out to me about this is one, it's an API, so it's not a runtime, it's not a system, it's not a deployment, it's really an API that you implement. And so and it's also it's focused on kind of simplifying the distributed stateful application. So these are the types of applications that we build and we need to have good consistency guarantees around. And stateful functions is really trying to make this a simpler process. And the way that they're doing that is by using Apache Flink as kind of the center of this distributed system that has a lot of heterogeneity outside of that. So if you consider a normal Flink process, there's ingresses, data bases or data queues or Kafka event streaming tools, and then there's a Flink cluster that's handling your processing, where you use the table APIs and you can use state APIs. And then there's egresses where you push data out, and then data might go out from there as well. You could even think of Flink being on the other side of this, or even on the other side of this. So you can really build kind of complex topologies with Flink. And then what stateful functions are adding on top of that is this layer right here, where you have another API that you can interact dynamically, with either with the outside world or with these ingresses, and build applications that are distributed. It could be distributed across Kubernetes or across Lambda functions or HashiCorp Nomad in this case, and you can then utilize Flink and all of the kind of learnings and state management from Flink to build this system. So what are Pulsar functions? So before I jump into that, this is a Flink conference and not a Pulsar one. So I'll just kind of briefly explain, what Pulsar is. So Pulsar is a distributed streaming platform. So it's really not only about, messages and distributed pub sub, but it's also about how to store those messages and then how to build a very modular system in order to take advantage of this paradigm of messaging. And so as far as Pulsar functions are defined, this is from the Pulsar functions website. So they say that Pulsar functions are lightweight compute processes that compute messages from one or more Pulsar topics, apply user-supplied processing logic to each message, and then publish the results of the computation to another topic. So if you look at the bottom here, you can see topic A. You could think of this as a partition topic, and each space here is just another message in the topic. And so a Pulsar function would subscribe to this topic, and then for each of the messages in here, do some kind of processing logic on it, and then push it to a new topic. So you can think of these as, Pulsar function can actually subscribe to more than one topic. So you can have topics like A through Z, and then publish from like ZA through Z. And so that's kind of how more of a Pulsar topic topology is. It's very like one-to-one. And most of the cases you see, you're reading from one topic and then pushing into another. And so it has a very, simple ideology. It's really about, processing messages and pushing it to another topic and being kind of very simple about what the project is trying to accomplish. So let's talk about the stateful functions runtime. So what's included? What do you need to run stateful functions? So for stateful functions, you need a Flink cluster, and then you also need applications that implement the stateful functions SDK. Currently, the SDK languages are Java, Python, and Golang. And you can think of the stateful functions runtime as kind of your existing Flink infrastructure, and then these functions that are outside of the cluster or within the cluster. We'll talk a little bit about those different ways to deploy it in a minute. But it's really about providing another API or another mechanism for dealing with messages, and then on top of that, by providing that new way of doing things, really kind of opening up the possibilities with Flink and what Flink can do. By contrast, the Pulsar functions runtime is it requires a few more pieces. So one of the big pieces that you need is a full Pulsar deployment. So Pulsar has Pulsar nodes, which are essentially JVM processes that are the kind of entry point for Pulsar. These are where clients will connect and consume and produce messages to. Each Pulsar node, it would be the leader or representative of a topic or a topic partition. And then Zookeeper is also here, which is the metadata storage for both Pulsar and Bookkeeper. They actually both use Zookeeper. And then Bookkeeper is the storage backend for Pulsar. And Bookkeeper is really incredible at storing data and providing some great consistency guarantees, as well as some really good failover characteristics as well. And Pulsar functions can be deployed on a couple different mechanisms. So one is, as depicted in this picture, this FN. You can deploy them on a Pulsar node, You can also deploy it, outside of this system on its own hardware or own VMs. And then the most popular way would be the Kubernetes cluster. So, really the future of Pulsar functions is on Kubernetes, and there's a lot of effort to just kind of enable more of the functionality of Pulsar functions on Kubernetes. And the last thing I'll say is messages come in and they're handled by the brokers and then eventually stored in Bookkeeper. So with the functions, you could think of them as a consumer. So they're really consuming messages as they come in, and then processing them and pushing them to another topic. So they're interacting kind of directly with brokers. So what about orchestrating? And let's talk a little bit about that. So with orchestration, it's all managed through whatever platform these functions are deployed on. So for stateful functions, you can deploy your stateful functions kind of embedded within the Flink cluster, or you can use other platforms like Kubernetes, for example, is a big way to deploy these functions. Serverless platform, so you could use Google Cloud Platform, whatever IBM's serverless function implementation is, AWS Lambda. That's all possible because, as we mentioned before, it's just an SDK. So you're just implementing some function code and providing some configuration for where your Flink cluster is, and then that's just kind of all managed, and all the discovery is managed through Flink at that point. And the same thing for Nomad. Like these can all orchestrate these functions because they're really just a HTTP gRPC mechanism for communication, which we'll get into in a second. And the management of them doesn't require much special outside of what's provided by the SDK and the runtimes. What about Pulsar functions? So Pulsar functions, like I mentioned previously, it really is all about K8s, so Kubernetes here. There's just tons of effort toward getting this to be a smoother experience on K8s, using stateful sets, and using services, using ingresses, even using secrets on Kubernetes to manage these Pulsar functions. So orchestration is really about orchestrating it on Kubernetes, and how you scale up your functions in order to meet the demand of the message volume. And you could use things like Kata, which is a auto scaling mechanism for messaging and distributed event queues on Kubernetes, and that's all kind of how Pulsar functions are looking future-wise. So you really would have your deployment outside of your Pulsar cluster, and then it would interact with the Pulsar cluster. So it's really kind of like a purely consumer model where the producing and consuming is all happening outside of the cluster, and then directly kind of interacting with the cluster APIs. So what about scaling? So with the Flink stateful functions, what you could think about is that each function should be behind kind of some kind of gateway or behind some kind of load balancer. So those load balancers are receiving communication from egresses that come in through the gateway, and then are scaled up by whatever orchestration engine you're using. So Kubernetes knows how to scale up based on traffic volume. Your functions as a service platform does too, like HashiCorp Nomad does as well. And so you wouldn't necessarily treat them any differently than you would any other HTTP service that you're deploying. They're really philosophically similar to those, right? They just can have kind of multiple ingress points, right? And we'll get into that in a second. They can have this Flink ingress point, but then they can also be served outside of this. And so putting it behind a load balancer is really the way that you can utilize these platforms, whether they be Kubernetes or a fast platform, Nomad or Mesos, if that tickles your fancy, or your own system, and you can scale these up based on request volume or other metrics around the functions. So for Pulsar functions, you don't quite do things the same way. So when you deploy these on Kubernetes, the idea is pretty philosophically similar to the stateful functions, but the difference really is that the Pulsar functions are not like an HTTP based kind of triggering. It's much more about messages coming in and then being more of a kind of a push into that function. And so scaling it up is really about being kind of smart about how the topic is partitioned. So if you do have a partition topic, and then it's also about being able to kind of configure your kind of topology around the messages correctly. So in this picture here, this is an example of deploying your Pulsar functions on the brokers themselves. And I mentioned already, like, this is not a way that we would necessarily want to do this, but it's just an example of how these functions can utilize the resources that are on these nodes, and they can scale up based on the message volume that they're processing, and you can create kind of clones of the same function to process messages and kind of consume from the same subscription if that's what you want to do. Okay, so let's talk about state management. So how you manage state, and it's worth taking a step back to think about why you would want to manage state in the first place. So in Pulsar functions case, we're really trying to go from topic A to topic B, and in the stateful functions case, it's not quite that same topology, but it's really about providing some kind of logic on top of whatever ingress we have, whether that's a message from a queue or if it's a HTTP request. So why do we need state? Well, if you think about the kinds of applications that we build, that require distributed systems, they're all stateful. So we're trying to build a shopping cart, or we're trying to build an app that handles shipping deliveries, and these all have state, and the state management can get complex. And so these projects, both stateful functions and Pulsar functions, provide some APIs in order to help us deal with that. So let's look at the stateful functions one to begin. So to start, stateful functions has an API so for the SDKs, the Golang, the Java, the Python, they each have kind of a table API that allows the functions to have state that persists, and be able to do things like delete, put, and and retrieve, get objects from that state store. And then Flink, its snapshotting model is a thing that kind of makes it so that it's just persistent and fail safe. So we all know we can do snapshotting with Flink with HDFS or S3, and so we can rely on that. So if the stateful functions don't need any more storage than that, so as long as their data can be modeled in a way that is kind of a key value, kind of a key, like a hash table type of a implementation, then that can be really its persistence. And so that's one of the real selling points of stateful functions is, the persistence is kind of, out of the box, and you can manage it that way. So let's take a look at an example of state management in stateful functions. So we have a couple of things here. So first, we're importing v3 of the stateful functions project, or SDK, excuse me, and then we're importing the time API in Go. And then we have a struct that is a person on line 6 here, and the person has a visits, and that visits is a stateful function value spec. So these value specs essentially allow you to share these types kind of across the whole Stateful Functions SDK. So sorry, this whole Stateful Functions kind of deployment on Flink. So the things that you can do here with state are you have this context object. So each of the Stateful Functions implements this invoke function, which is essentially the way that you should behave once you receive a request as a function. And that function takes a context object and then the message that is the stateful function message that is being sent to it. And then it can use storage and the get storage, and then it can mutate storage as well, and setting storage, and then it can return whatever it is that it needs to return. And so state management is pretty simple, right? We've got this API that we can get and set, and then we can also delete things as well. And so we have full control over like the types that we store in there, and we can use the type system that's provided by this value spec, and be able to use that for our stateful functions. So how does that compare to Pulsar functions? So Pulsar functions utilize Bookkeeper. So I mentioned before that Bookkeeper is kind of this indestructible storage engine that's really battle tested, and effectively each bookie, so a bookkeeper cluster is composed of bookies. So each server is a bookie, and it has kind of a similar API to what we saw at stateful functions, where you can get, put, and delete objects that are stored in kind of a table format. And this picture's an oversimplification here because we don't necessarily interface kind of directly with Bookkeeper. There's a API that the stateful functions, or so not stateful functions, but the Pulsar functions provide that enable this kind of same usage without requiring kind of all of the semantics that go into storing things in Bookkeeper, which is a little bit more complicated than what's displayed here. So let's take a look at an example. So this is a stateful function. I'm sorry, it's not a stateful function, it's a Pulsar function. I mixed up my words here. That is using some of the same kind of state management patterns that we saw in the stateful function. So we've had to do a couple imports. So we import our functions, dependencies here, and then we import a Java array. And this is in Java. With other example was in Go. But effectively, we're doing a double word count. So for every word that we see in a message, we're going to double it in our counter. So similar to the stateful functions, Pulsar functions has a process API. So every function has to implement this process, and it has input. So it's similar to the message that we saw on the stateful functions, and then it has a context object. And so on the context object is similar, like on line 13 here, where we can actually have a counter. So this is a state object that we set a key on. So in this case, our counter key is like a word that's pulled from this array that's a pull from the words in this topic. So this topic is a string, and then we just add 2 to it. So we increment it by 2. And so you can see that the state management is similar, but the kind of advanced thing that's here is like an actual counter API. So you can keep a kind of a distributed global counter for these functions as well in Pulsar functions. And the way that you deploy these functions, I think, is important. So we kind of package up our jar. We use the Pulsar admin API to create a new function. We say which class we want to use. So in this case, double word count function. We select the tenant because Pulsar is multi-tenanted. We select the namespace. We give our function a name, and then we say what inputs we have. And so in this case, we're just using a topic that's called raw, and then we have an output that's a topic that's called double. And so that's kind of the extent to what it takes to create a Pulsar function. So let's talk about the ecosystems and compare those real quick. So the Flink ecosystem for stateful functions is completely open. So anything that you can do from an ingress or egress perspective can be managed by your Flink cluster. And so you have access to Kafka and RabbitMQ and Kinesis. And as of kind of the most recent release of Flink, you also have access to Pulsar. So Pulsar could be an ingress for you here as well. So that it's a very rich ecosystem. It's tried and true. You can build very rich APIs with stateful functions based on just using these as ingresses to kind of have these be the input to your stateful functions. And then in the Pulsar ecosystem, Pulsar functions are really about integrating with Pulsar topics, right? They're not like the stateful functions that have kind of more wide ambition of being general purpose compute. These are very much like you start with the topic and then you can go to other topics. And that's really the extent of the ecosystem. That said, the Pulsar functions is implementing an SDK, right? So it's Java, it's Python, it's Go. So if you want to, within the lifecycle of your process method, interface with anything, a database, another HTTP method, you can do that. But it's not sort of this out of the box experience where you're saying topic A in this picture here. So instead of this being topic A, this is Kafka, and then your Pulsar function process that, and then topic B is Elasticsearch, right? It's not like that. It's much more about just dealing with these topics and publishing to other topics. And that's really currently, and I'll talk a little bit about kind of the ambitions there in a minute. So what are some key differences between these two projects? So the first one I would say is Stateful Functions has the serving aspect. So you can serve Stateful Functions as a RESTful post endpoint. So you could think of this as a new ingress method to the stateful function. So instead of the ingresses being managed through Flink, you can just have your own place where you post, and then your function has some logic, and then you can egress out into all the egresses that are provided by Flink, or other egress any egress that you want to provide. So stateful functions has like an egress API, and you can build your own egresses if you want. So that's very philosophically and implementation wise very different than Pulsar functions, right? That this is not something that Pulsar functions does. It's not meant to be this API that you can hit. It's really kind of self-contained. Its input is a Pulsar function, its output is a Pulsar function. But this is really opening it up to be different, and you can see this model kind of extending beyond just HTTP, which is pretty fascinating. And then also stateful functions communication patterns are much more flexible, right? So functions can egress to other functions or be ingresses from other functions. And so you can really compose a topology of these that are, acyclic graphs or other types of graphs. If you have the flexibility to do this, and that's not the same flexibility that's granted in general by Pulsar functions, although that's changing. I'll talk about that in a second. But this is really unique, and it's different because the approach and the goals of the projects are really different. Whereas stateful functions is trying to enable you to write APIs that are part of this distributed system. Flink is really about stream processing and kind of keeping a simple runtime for those. And so let's talk about Pulsar function mesh. So this is in beta now, and it's kind of part of the open source project, but it's pretty new, like a couple months old, and it doesn't have the kind of traction yet to really say that it's kind of at the maturity that stateful functions are. But what the function mesh is it's really this idea that you can kind of orchestrate functions together. So you can use these functions in conjunction with other systems through Pulsar IO, which is an API for doing mostly like change data capture with Pulsar. And you can mesh them together and create these kind of like directed acyclic graphs, or just graphs in general of functions, and do kind of more complex stream processing. So that's kind of the future. It's still not allowing you to serve any of this as a HTTP endpoint, but you could think of it as like the topic will still kind of be the ingress, but then the egress could be kind of much more, many more things, including other Pulsar functions, which would be really kind of expansive, for what the idea was based on. So let's talk a little bit about the programming models, differences between the two. So Stateful Functions has a very kind of type-oriented, model for its Stateful Functions. So there's a lot of code here, and I wanted to do this not as like a complete application, but just to show like some of the possibilities. So you can see here at the top, like we have a Kafka egress builder. So this is a kind of a built-in stateful function egress builder, and we can do things with types, and we can send messages to specific topics, and manage the keys for those topics as well. And then we have things like the stateful functions type. So each type corresponds to an address. So every time you make a function, it has kind of an addressable namespace. So you could think of it as like, okay, example person, is an application out there, that does handle like persons, or does greets, or greeter. And so it's a very kind of expansive and really kind of customizable SDK. And then going to the bottom here, we can do things like get state, remove state, set state, and we have this kind of context-driven model as well. And in the middle, so lines 20 through 24, we see that we have even things that like expiration. So we can set the values of our data that we're transporting to expire after some time. So that can be useful for things like security, or just trying to kind of set a bound around when messages to be processed, for example. And then the Pulsar functions programming model, using the Python SDK here, has some similarities, but really has some kind of differences. So we can do state management. So we can do things like incrementing this counter, as we discussed before with our double word count. We can also do serializing and deserializing with Pulsar functions. So we can make our own custom serializers and deserializers. So this is creating a way to kind of decompose tweets, for example. And then it's really context driven. So every function has this kind of context object, and then we can use that context object to perform work. So let's talk about high level comparison. So Stateful Functions is really a microservices oriented framework. It's about kind of giving you the building blocks to build a stateful kind of distributed application, or several applications, on using Flink as kind of the backbone. Pulsar Functions, by contrast, is really about stream processing. It's about taking data from a topic and then processing, moving into another topic. And they both share kind of the same SDK runtimes, right? So they can do Java, Python, Golang, and then they both can run on Kubernetes. And you'll notice from the documentation for both of them, a lot of the examples are using Kubernetes. And then you can orchestrate with Yarn for your Pulsar, or sorry, for your Flink cluster. And then Pulsar is part of the kind of distribution for Pulsar functions. So they both can scale horizontally, based on HTTP traffic for stateful functions and based on message volume for Pulsar functions. State management is handled by Flink in the stateful functions case, and handled by Apache Bookkeeper in the Pulsar functions case. And then you get full access to the Flink ecosystem and any external system really too. And in Pulsar functions, it's mostly about the now, right? So it's about using Pulsar topics, but the future really is about function mesh and being able to really extend the paradigm there. So for conclusions, like Pulsar functions are really focused on Pulsar for now. Stateful functions have wider ambitions in stream processing and could be interesting for a lot of implementations. Both have really rich APIs and can do state management, and both can utilize Kubernetes. And it seems like, even for the stateful functions case, that's kind of the way forward, like the way to do scaling for those, as well as the same for Kubernetes with Pulsar functions. As for resources for this talk, the stateful functions documentation was excellent, for helping me to make sure I'm kind of saying things properly with regards to this talk. Pulsar functions documentation, it's the same. And then stream processing with Apache Flink is a great book from O'Reilly that I utilize for just kind of making sure that everything I'm saying kind of aligned with the project here, and just was kind of providing a historical context backwards. And then with my own book here, so Mastering Apache Pulsar, which is coming out at the end of December, for anyone who's interested in Pulsar functions can read that and learn more about it as well. And then my slides, I'll share them on my Twitter at some point after this conference. And now I'll take any questions.